All right, guys, you're ready for Unit 5.2b. Now, this is basically word problems. So the big thing here is determining the measure of the sides and the angles of the right triangle using primary ratios. When you want to measure the height of an inaccessible object, like a tree, a pole, building, cliff, we can utilize concepts of trig. Two of the things you're going to need to know here is angle of elevation. And if you look at the person looking into the line of sight straight across the bottom, and the angle of elevation is going to be inside that triangle. When we're looking at angle of depression, we're looking at this angle in here. Now, oftentimes, you're going to have a triangle down here on this piece, and this is what you're going to need to use to solve the triangle, that angle in there. If you do 90 minus your angle of depression from outside, your angle of depression here is going to be in blue, you end up getting that inside angle, and that's what we're going to be dealing with. So, what you want to do, sketch a triangle. If one hasn't been provided for you, label the given sides, including the variables and the unknown sides that you're looking for. What are you looking for? And write the trig ratio that you're going to use to find it. Then substitute wherever you need to get the information. So here we go. If the distance from the foot of the tower is 20 meters where you're standing, so you're 20 meters, and the angle of elevation is 40 degrees. 40 degrees. How tall is the tower? We're looking for the height x of the tower all the way up to the top. It stopped here, so we're going all the way up. So if we look, we have at the angle, we have 40-degree angle, we have opposite and adjacent. Opposite and adjacent is tangent. So the tangent of 40 degrees equals my opposite over my adjacent, 20. Remember, if we have these ratios, put it over 1, cross multiply, and we get x equals 20 times tangent tangent 40. That gives us 16.78. So we're going to call it 16.8. 16.8 meters. Don't forget your levels. That's height for our tower, 16.8 meters. All right, so we're looking at a castle now. We got a boat. The angle of depression, if you remember the angle of depression, is going to be here. That's our angle of depression. That's 25. Which means that inside angle in here is going to be 90 minus 25, which is 65. We're talking about a 65-degree angle that we're looking at inside here. Let me see if I can do that. If you can see it any better in here. Okay, so this definitely wasn't drawn very well. And the boat is 50 meters from the base of the castle. 50 meters. All right, so looking at our angle up here, we'll use some yellow. Our angle, we have opposite, we have adjacent, so we're dealing with a tangent again. Tangent of the side I'm looking for, how tall, x. So the tangent of 65 equals my opposite, 50. Over my adjacent x. In this case, like I said, we have the x on the bottom. So if we did it by proportions, we could switch the tangent 65 in the x. And that's exactly what we're going to do. We're going to get x equals 50 divided by tangent 65. We get 23.3. So our height of our castle is 23.3 meters. Gotta be careful your labels, see what they're giving to you. You walk 40 feet from the base of a tree. When you look at the tree, the angle of elevation to the top is 70. So I'm going to draw a tree over here. You walk away 40 meters. Roughest time of this. Ooh. You look up and you have a 70. You have a 70-degree angle in there. What do they want to know? How tall is the tree? So you have to draw your own picture. And we get opposite adjacent. So tangent again. Tangent of 70. Ooh. Equals opposite over adjacent. So 40 times tangent 70. We get 109.899, so 109. Oh, 9.9, and this time we happen to be in feet. Very good. So run on example 4. You're at the top of a building looking down at your friend who's standing 55 feet from the base of the building. So you're up top here. You're up here in green. You're right on the edge of that building, looking at your friend's shoe. He's 55 feet away. He's not like to make fives at all. He's 55 feet away. You have an angle of depression of 57. So what is your angle actually inside there? 90 minus 57 gives you 33. You have 33 degrees in there, and you got a side. And what do they want to know? How tall is the building? They want to know X over here. So again, we got a tangent opposite adjacent. So the tangent of 33 is 55 over 55 over x. So 55 divided by tangent 33 gives us 84.69, so 84.7. 84.7 feet tall still. Next example. TV towers, 190 or 175 feet tall. 9, 7, 5. And it's held by guy wires. Guide wire comes down, or guy wire comes down. That's your angle to the top. Wires make a 58 degree. Angle with the ground. How long is the wire? We're looking for X. In this case, we're looking for the hypotenuse. We have the opposite, so we're going to use sine. (58 degrees) equals the opposite, 975 over X. And that would be X sine 58 equals 975 divided by sine 58, and you get 975 divided by sine 58 equals 114.969, so 0.7 feet. That's how long the guy wire is. And yes, they're called a guy wire, GUI, not guide. All right. From a hot air balloon 2 miles above the ground, the angle of depression to 2 towns in the line with the balloon are 81 degrees and 13.5 degrees. All right, so let's make some ground here. And we've got a $2-kilometer. And I think we'll make this one go like this, make that one go like this. This is going very straight now, isn't it? All right. 2-kilometer high. And our angle of depression, remember we have to do the angles of depression. This is going to be the 13.5. This is going to be the 81.2. We need the inside ones. So 90 minus 13.5 is 76.5. And our other one over there is 90 minus 81.2. That's 8.8. So we'll call this piece X, call this piece Y, and we're going to have to do 2 different triangles. So the first triangle, we're looking for opposite over adjacent, tangent of that 8.8, that angle equals my opposite over my adjacent, which is 2 kilometers. So 2 times tangent of 8.8 equals 0.3. So X kilometers. Y down here is going to be tangent of, what was that again? 76.5 equals my opposite Y over my adjacent 2. So 2 times tangent of 76.5 is 8.3. That's y. That's x at 0.3. Add them together, and you get the towns are 8.6 kilometers apart. 8.6 kilometers. So that was a double triangle problem. Sometimes you have to work with double triangles. So to solve a problem involving two right triangles, using trig, draw and label the diagram using the given information. Look for what they give you. Identify the two triangles so you can be taken apart if you need to. Solve the problem and show each step. I'm going to try to give you guys lots of practice to work on these things before we put them on your test. So this one, they already labeled it all for you. So somebody's standing on a roof at B, looking up to A and looking down to B. They want to know how tall both buildings are. So what they really want to know is what that side of the building is, how tall it is, and how tall is that one. Well, in order to get the second one, I'm going to need two pieces. But the first one, I only need one given my information. I have an angle, and I have an opposite. Well, I don't have an angle yet. I have an opposite and an adjacent, so I'm going to be using tangents. I just don't know what my angle in here is. Well, the angle in here, if you remember, when you're split, two parallel lines split by a transversal, the alternate interior angle, so that's going to be 53 degrees, just like it is up there. The other way to do it would be find this piece, 90 minus 53, and then take 90 minus that and come back to your 53 down here. So this is our 53-degree angle. We have tangent of 53 equals the opposite over the adjacent, which they gave us is 18, because two buildings are 18 feet apart. Okay, so 18 times tangent 53 gives us 23.886, so 23.9. So the first building, the shorter building, is 23.9. What was that in feet? Meters. 23.9 meters. First building, X. The shorter one. The other building, Y. Well, we need to find, working in this triangle up here, we know this is 18. Because that 18 carries up there. We have 44. We need to find this little piece over here. So that little piece, not Y for the whole thing, that little piece up here is Y. So let's go ahead and do that. We have opposite and adjacent. So again, we're at tangent of 53 equals the opposite, called Y, over the adjacent of 18. No, sorry, that's not 53. That's my mistake. What's that angle in there? That angle on that top one's not a 53. That's a 44. So 18 times tangent 44, which is 17.38, which is going to be 17.5. Oops, 4, 38, 4. Adding our two sides together 17.4. It's also in meters. Plus our 23.9 original building. And we're going to find out how tall the whole building is there, the two pieces of the triangle. And we get 41.3 meters tall for the whole building. So here you got a shorter building and a larger building. I'm going to change this problem up a little bit from what you have on here. We're going to change AB to AD because AB is really easy to find. Matter of fact, I'll go find AB first. That's from here to here. I'm going to call that X. When we do that, when we look at these two angles in here, we add them together, we get 50. So what we have is a 50 looking for X and a 120 at the bottom. That's opposite and adjacent. Again, that's tangent. Tangent of 50 degrees equals my opposite over my adjacent. Multiply 120 times tangent 50, and I get 143.01, so let's call it 143 meters. That is my whole length, my whole triangle. Now, I want just AD. So I want just this piece. I'm going to call it Z. To get that, I need to have that piece Y. Then I can subtract it away from the X, and that'll end up my piece of Z. So that triangle is a 20 degree with a 120. Side, and I'm looking for Y. So tangent of 20 equals Y over 120. 120 times tangent 20 is 43.67, so we're going to call it 43.7 meters. Subtracting those, 143 minus 43.7 gives me 99.3. So AD, 99.3 meters. And 9.3 meters. In our last example, you're looking at the window of an apartment building 120 feet away. The angle of elevation of the top is 23.2 and the angle of elevation of the bottom is 46.2. How tall is the building? So you are in a building here. You're here. And you're looking out at this other building. And it's going up. You go straight across. You have 120 feet. What's this 120 feet away from you? Straight line. Your angle of elevation is 23.2 degrees. That'll give you an X because you use tangent opposite over adjacent. Your other piece you're looking at is you're looking down. And your angle of depression, which happens to be inside here again, is 42.6. So that's your angle. You need this piece over here, Y. You have the 120 still. So opposite over adjacent again. So for your top one, tangent of 20 43.6 equals your x over your 120. 120 times tangent of 23.2 is 51.4. And that is in, what are we, feet here? Yep, 120 feet away. Well, that's the top part of the building X. Let's go find Y. Tangent of 42.6 equals Y over 120. 120 times tangent 42.6 is 110.3 feet. That's the two pieces you're building added together. And you get, how tall is the building? 167. Whoops, my bad. It's 161.7. .7 feet. And you just figured out how tall the building was. Well, guys, these are word problems. You're going to have a whole section of tests on these. So, I know you can handle them. Good luck. Do your worksheets that are given to you. And we will come back next week and look at them all over again and see what we can do with this. All right. Thanks for doing your work. See you later.